Okay, thank you, ladies and gentlemen. If you could please take your seats so we can resume as quickly as possible to keep within the allotted time frame. Okay, thank you. If you could, after the excitement of the photograph, if you could please settle down, and we shall start in as soon as everyone is ready. Good, thank you very much. I hope you've all had a nice lunch and you've had some time to think about the very excellent presentations we've had this morning. We have, for the rest of the afternoon, we have 2 more presentations, plus there will be a very short, unannounced third presentation, followed by a little bit of discussion, and I think we will certainly try to finish by 3 o'clock, because I suppose that many of you will have transport to catch and so on, so we will finish by 1500. So to start us off for the afternoon session with the unenviable task of keeping us awake after a nice lunch, Francois Christians from INRA Transfer will talk about the use of remote sensing, complex regulation and economic feasibility.
Well, thank you. Oops. And thanks to the excellent presentations of this morning, I've got some already drawn conclusions. So, as a matter of fact, I've got some good news and bad news. We talked about adoption level of remote sensing by end users. The good news is that there is a lot of drivers that help this adoption, but the bad news is that there are also a lot of restraints, which may explain why the uptake is so slow up to date. So I listed them here, and even if they are not, all the categories are not hermetic, most of them have been already discussed, and we can see them as oops, sorry. What's the pointer? Yes. You can see that there is some causes, some needs, and benefits which can be drawn from remote sensing. The first need end users have is to increase yields. That's basic. It may be an evidence, but they do need to increase yield just because already used techniques have shown that they are leveling off. I mean, genetics is leveling off, and the use of pesticides is leveling off too. So if remote sensing can bring them some kind of benefits, I mean some improving the yields, it's a big increase, it's a big advance, and it will be a big driver for them to adopt it. And the users' feedbacks, we have some of them from wheat, for example, from barley, and usually they can expect up to 5 or 10% more of production with remote sensing as compared with embarked sensor, I mean on tractors and so on. And in some configurations, this increase can be up to 15%. The problem is that the commodity price keeps on varying, and also meteorological condition makes this increase very small. Also, the crop scouting, which is one main driver to adopt, to be interested in remote sensing, well, it's due to the decline of labor force, the increasing average age of farmers, and also more and more farms are bigger. I mean, they cultivate a bigger size, and the main driver behind this is to save time and money. Time because the farmer or some of their employees do not need anymore to go and inspect very far fields. I mean, very far fields. It may be up to 20 kilometers away from the main habitation. So it's a saving of time. It's a saving of money because they do not need to run the tractor to go there and to inspect the crops. Also, because there is a lack of workforce, there is getting information thanks to remote sensing, bring them objective and shared information. Objective because it's brought to them by a device, and shared because they need to share this information just first between them, because there's a heavy tradition of sharing information, but also with other players such as suppliers or customers. So these two drivers are very effective. The next one is inputs need to be delivered as precision agriculture require them to be delivered. And as soon as there are some variable rate application which is available, well, cost savings are here. Here I should make a point. My presentation may be a little biased because I made some focus in some way to drones. It's not only about satellites, but also, well, sometimes I was pulled by the drone and their story, which is famous from, just because they boomed very recently, and we had to pay some interest to them. So also another benefit from remote sensing, well, from the carriers, not from remote sensing itself, is that some drones may be able to spray, well, to have control on the crops. It's not only a matter of sensing, of making prediction, of making prescriptions. It's also a matter of controlling what happens on the ground. And here it's kind of what happened at the lunch. I mean, I could see the food, I could assess it, but I couldn't grasp it, and it was a kind of frustration for me. So once you can control what is done, well, it works much better immediately. Also, the last for this slide, the last driver, is that farmers, if we consider farmers as end users, they don't have a lot of money, most of them, so they are very prone to switch from from capital expenditure to operational expenditure. I mean, they prefer services than investing, just because they don't have that money. And they also don't want to cope with difficult information to interpret. They don't care about which satellite needs to be used. It has been told this morning. They don't care if it's an aircraft, drone, or whatever, or a tractor. Well, what they want is to be able to use this technology in order to increase the margin, because they are here to sell food to people. Also, regulation, it's quite provoking, but it may be considered as a driver. Because regulation, as soon as the regulation allows lower qualifications for the drone pilots, the drones boom in agriculture. It's what's happened in France, it's what happened in the USA in 2015. More than 600 companies just flourished in a few months, just because the FAA enabled some pilots to operate. Environment preservation, and here we join the official recommendation and official requirements. What is needed is to prevent soil erosion and over-fertilization. Okay, so remote sensing can help to optimize inputs intake and waste of inputs. And the price of inputs has raised dramatically. For example, for nitrogen, it rises from, in a few years, from 0.20 euros up to 1.20 euros. And that's a big difference for the farmer. Well, if he can, it's not only a question of environment, it's also a question of saving, directly savings for him or for her. Well, the climate is changing, okay, already everybody knows it, but water resources and pest infestation needs to be monitored, and these changes, and maybe at this point, satellite long-time series may play a role. Just because to pinpoint a change, you need long-time series. The last point on this slide is food traceability. Consumers want to be reassured about what they eat. In Europe, at least, they are very worried about what they can eat. And they have to be confident. And so they use transparency as a proxy for confidence. Remote sensing can bring some data as independent, objective data, which can be certified by another company, and this would bring some reliability and some help to guarantee the reputation for territories. An authority, maybe an official one, or even blockchain, which is developing. But I told you there were a lot of good news. It's the last slide about it. Sorry, but there are still good news. What they need, the end users? They need low prices and high-tech techniques. The good news is that satellites and drones are spillover markets. It just means that these sensors and first-level analysis devices have been already written off and optimized as far as their size and energy consumption is concerned for another economic sectors. For example, for transportation, for heavy industry, etc. And so they already come with reduced prices, and this is why they are so widely spread and can be paid by farmers, by researchers, by anybody. And also another kind of good news is that agriculture is an open ground. There is not a lot of equipment about drones, as far as drones are concerned. So it's a virgin area, and so there is no competition. So for providers, it's okay, it's a good news too. It's a driver, but a little less powerful. The next one is about quick financial compensations. This is driven by parametric insurance. The parametric insurance is a system which is promoted by the European Commission, which is already developed and may apply more evidently to crop fields than, for example, vineyards. It enabled automatic triggering of compensations. And so you only need devices with objective measurements. You do not need to call for an expert to come and to see, okay, these wheat have been hailed, or something like that. The next one is the implementation of agroecological practices. The common agricultural policy, yes, will require some results to be measured, and so it may be a card to play for the remote sensing, just because they provide measures. That's this evidence. The next is not for farmers, because farmers may not be the right end users. as the first target. Maybe a better target would be seed producers, just because DNA sequencing speed has increased dramatically, and it has overtaken the speed, the Moore's law for semiconductors. So the bottleneck now is in phenology. It is what prevents seed producer to put on the market new seeds. And so there is some market to develop, some money to be made here by proposing efficient technologies. So, on the other hand, there are also bad news. The return on investment, it comes directly from the farmer's income. Okay, for seed producer, the income is not the same, but the return on investment is very hard to calculate. And in addition, it requires new business models. And the income of the farmers is directly linked to the commodity prices. And as long as the commodity prices are low, the farmers won't have the possibility to invest or even to pay for services. And this is a very heavy restraint, maybe the major one. In addition, the return on investment, there is a problem because when we switch from maize to wheat to vineyard, the lessons which have been learned the hard way from one crop are not necessarily transferable to another crop. And so you have to develop not from scratch, but almost, and it's very heavy. What the need also is to monitor large areas. This need is specific to drones. Drones today still need pilots, and this is due to regulations. Rulers don't, they send eagles, but they also send heavy rolls, and this is one. You still need today a pilot to drive a drone, and this costs a lot of money. This is why there is some development about autonomous drones. And crop information also. There are some kind of competition with other technologies which can provide information such as a wireless sensor network, but all weather and constantly. What the end user needs also are actionable information, of course. This means that data are not need some translation because there is at least a two-step calibration procedure, which means transferring the image which is acquired into a reflectance image and then reflectance to a prescription map. And this procedure, these steps are far from evident. And so new skills are required. And the farmers don't have these new skills. So that's a kind of a hurdle. Also, farmers don't understand this technology most of the time. So they are reluctant to adopt it. It's a matter of mind. They cannot grasp it. The satellite goes overhead, even if they don't want it to. They cannot prevent it. Drones, they have a kind of control over it. And what is delivered by drones, by satellites, is data. Okay, data is nothing to a farmer. Well, nothing. Except for early adopters, but it's not crop. It's not money. So it's intangible. You can, So this is changing, but yet today it's still a restraint. One of the biggest restraints too is a variable rate application. If you are not equipped with a device which enables variable rate application, you can forget remote sensing most of the time. When we are dealing with crop fields, vineyards, or flowers cultures. So prescription maps are almost useless without VRA. And also there is about data, there is some kind of debate about the property of data, because farmers just feel that this data has some value, but they're okay to share the data, but they want to be paid in return at the fair share. So for the bad and the good news, there are drivers, before this, yes. There are drivers, there are drawbacks, benefits, okay. The good news, the overall good news is that there is no killer restaurant. This means that there is a kind of equilibrium and the balance is toward the benefits. And this is why there is still adoption ongoing of remote sensing among farmers, etc. About the market now, the precision agriculture markets, some figures here can help us figure out if it's interesting to develop remote sensing. And here are some figures I could get. They are quite old because they are 4 years old now, but more recent figures are even more optimistic. So we can see that for Europe there is more than $300 million market which is expected for 2 years. Well, for agricultural drones only, figures are fantastic, but so widespread I cannot believe them at this. I indicated them, but I'm not very confident in them, because a market of 5 billion euros, well, I would like to trust it. The variable rate application still is the first step to be solved. This is, yes, it's here. It's the first step to have a good remote sensing, a good precision agriculture market is to have variable rate application, and then remote sensing. And remote sensing includes different techniques. There are some criteria for different techniques to be from different so-called smart agriculture, enabling technologies to be adopted. The market, okay, is the first column. The speed of adoption, the likelihood of occurring, the impact on food and agriculture value chain, the maturity of technology, and the impact on farmers' earnings. You can see the agricultural drones are on the top of this list. This is the good news, with sensor fusion. And HSI is hyperspectral imaging. It ranks quite well too. You can see also that satellites lack of this table. Well, so it's still a good news for remote sensing, considering that satellites are not the first technology to be adopted. I mentioned that drones, at least drones, and also knowledge about how to interpret data means new business models, which can induce reluctance for farmers to adopt this technology. I can see about 3 different business models. You can sell some drones or, well, drones, yes, or as a service. As a comparison, it's what some tires manufacturers do. For example, Michelin in France, which makes tires, it doesn't sell tires anymore. It sells tires for planes, but it sells a number of takeoff and landings, guaranteed. So they sell not the product, they sell service. This is one way to cope with the technology and to transfer it. You provide the equipment, but you also provide the maintenance, you also provide the upgrades, because but you can focus on a specific technology. Here it's drones. It's what has been done by Netafim, for example, the well-known irrigation Israeli society startup. They provide free equipment, free maintenance, free upgrades, free data. Okay, so the business model, how do they make money? just because they take some percentage of the increase of the yield, because irrigation is a major problem in Israel. But weather is very easy to cope with in Israel too. In some places, it doesn't rain from March to October. Okay. The second business model is data as a service. So you don't sell a drone or a satellite something. You say you need data about your field. But this business model is going to fade out just because farmers don't want data. They want results. Data is hard to interpret. And also it could be seen among venture capitalists. They used to fund startups who would provide a lot of data, big data to farmers, to cooperatives, etc. And recently they closed the faucet. They say, okay, not money anymore, and startup started to die, as expected for a startup, just because data is not enough. Either you sell something, you sell a drone to, not to a farmer, but to a seed producer, to a cooperative, or you sell process. Data is just something you cannot use. So process as a service is the third business model. You sell not the data, but advices. And this is where research may have something to transfer, which is far from easy, but which is maybe more comfortable for researchers, because they want and they may want to inject some knowledge about not crop management, but diseases detection, etc. So here I am to the key takeaway findings. I separated it between the two vehicles, which are drones and satellites. Main thing to be reminded is that benefits exceed drawbacks, which is a good news of all. Drones, everybody has one. And so there is a very low negotiation power from suppliers. So there is not a lot of money to be made using drones. Services may help. Regulation, okay, it's driver, but not only, as mentioned, as English may have it, it has its foot on the oxygen tube. As soon as it lifts the foot, the industry goes very well. And the trends which needs R&D inputs, there are 4 of them, which I can quote here. There are autonomous flights, just to cut out the cost of a pilot. Even if regulation is not ready here now, it depends on countries, it depends on trials, and trials are being made today just to influence rulers. Enhance endurance, especially for drones, obviously, not for satellites. Spraying. There are spraying tests which have been granted by sanitary authorities in almost any country, in Poland, in Italy, in France, in the United States. Well, at least all of these countries are being running tests for spraying. I'm not talking even about Japan, which is spraying, which has been spraying for a lot of years now. Spraying also it's a good news for the farmer, because when you spray with a drone, you act. It's not only a prescription map, you directly have the result on your crop, and it's one of the main advantage of the drone is that it can replace the lack, it can help to compensate for the lack of labor force. I mean, 3D is dull, dirty, dangerous. All these tasks which are dull, dirty, or dangerous, which may be replaced by a robot, by something automatic, is welcome. And also one trend, as we can see with agricultural machine, is swarms. It's constellation for satellites, it's swarms for drones. For satellites, there have been 179 launches for between 2005 up to 2010. 2014. But there are more than 400 which are scheduled for the next decade, from 2014 up to 2024, which means that heavy payloads are still here to dominate the market. So it was just a kind of pre-answer to tiny satellites that we may be aware of. Miniature satellites are here. They have made their proof of concept. The proof of performance is yet to be done. And well, I'm gliding over the last point because it has already said this morning. We all know the hype curve. The visibility of any technology versus time varies. First, the technology triggers, and then there's a peak of inflated expectations. Everybody talks about it. And then there is a trough of disillusionment, where everybody forgets about it. And then it reaches a plateau of productivity. And we can try to set where is remote sensing according to this curve. Satellites and aircraft are here and have been there for a long time now. So satellites, aircrafts, they are on the plateau of productivity given, well, the only restraint is the commodity prices. Drones are going up, and this is good news for them because they are, well, the players on the drones market, they are only a happy few now. The market has cleared. But tiny satellites, you can forget them just for the moment. They are not ready. So to conclude, only a focus about evolution of drone technology. It's not a map, but we can say, okay, we are here. It was an introduction, but what we can expect is beyond visual light of sign operations, which is very critical also to have good results. And this is developed. This is already the case. For example, Deller Tech, which is a French company, has the authorization, so it manages the complex regulations, and also the technical know-how to have flights which don't require pilots, and so they can operate over big crop fields, and especially they want some markets about rubber trees and palm oils, and they can provide data just to which are very usable to guarantee that there is no deforestation and there is no bad use of land for these specific cultures. Thank you for your attention.
Thank you, Francois, for that very good sort of analysis of the state of the sort of market for remote sensing there. I think there's some very interesting data there. We'll now move on to the next presentation, which was from the speakers we've heard before. Is a joint presentation, I suppose,
yes.
In which case I will leave you to introduce yourselves.
Yes, thank you. I just wait. Okay, so it's a joint presentation also because we are part of this initiative, which is an Euphresco project, research project on the application of remote sensing plant health, which names FIRST. And we have this partnership from UK, from Italy, and from also collaboration from USDA, and from a company, and from GRC. So it was a first attempt to have a joint collaboration. And I share this presentation with Paul Brown. And so I try to remind a little bit the problems of pests and diseases in general. That, of course, we have a problem of introductions and establishments, and this is increased by the problem of global trade and climate change, especially for the establishment, and so for the invasions of most of these species are, of course, may invade, like we were saying this morning. We don't know who is the next, who is the name, what will be the host. And so the problem is that once established, it's very difficult to eradicate. So, and they can destroy entire industries or specific crops or a forest system. So it's very important to try to prevent, because it's economically, environmentally more efficient than eliminating pest outbreaks from which infestation or infection can fast spread. And this is a very important issue because we speak about, for example, in this today, remote sensing or many other tools and techniques which are expensive. But in reality, if we think how expensive it is to manage an outbreak once it's already there and you cannot do anything more, well, I think that mainly politicians should understand this issue that is economically convenient. So it's very important, and I want also to remind that, of course, it's the rule of MPPOs to protect plants from regulated quarantine, non-quarantine harmful pests. And I just brought two cases. One is Xylella that is already known, and one is plant pox, for example. But just so to early detect pest introductions and spread, it's important to have efficient systematic surveillance systems in order to apply immediate phytosanitary measures. So this word is a key word, immediate. So it means earliest you are, more successful is your surveillance program. So we need performing methodologies and tools, skills, and adequate financial resources. And I want just to make you understand the context of the Euphresco project of FAIRS, which is inside of a strategic agenda, research agenda about the Euphresco Priority 4, which is the objective is to explore the use of remote sensing technologies to support surveillance and detection activities. So early detection of pests is important to limit crop environmental losses, to prevent further expansion of outbreaks, facilitating containment or eradication campaigns. So in this context, the strategic agenda of Euphresco is, of course, proposing satellite piloted aircraft, which can provide precise maps on the Earth's surface, but also to reach, this is very important, we didn't stress a lot this morning, locations that are difficult to survey, because when we go for survey in the field, we may not reach all sites. So in reality, there are some sites that you cannot investigate on the ground. And you need to investigate because those sites could be, of course, outbreak area, and we don't know. So the remote sensing may play a very interesting role in this. And, of course, remote sensing must be this platform, can support sensors, different types of sensors. Of course, the combination of more sensors is advisable for a better and more accurate detection. So further detection of biotic stress in plants even before symptoms develop. So in the Euphresco agenda, we are speaking about early warning. And so the project FAIRS was aimed to explore current research undertaken mainly at the project partner institutions, report on benefits and limitations of remote sensing application plant health, mainly concerning pest surveillance, host mapping, plant host mapping, and pest outbreak monitoring, pest spatial and temporal, and spread. But also to evaluate the effectiveness of applied measures, because when you have to deal with these pathogens, you have to immediately apply phytosanitary measures as regulations, following the regulations. So, but you have also to evaluate the effectiveness. For example, in eradication of an outbreak, to see if the eradication is feasible or not, you need to make such an evaluation. So it's not only for the monitoring the pest outbreak, but also to evaluate the effectiveness of phytosanitary measures, the environmental economic impact and cost effectiveness, and also further measure for containment eradication actions. So means that are supporting decision maker. And just one slide showing the project was divided in two phases. And so the first phase was to bring together this expert to map and review current work in each partner institution, identify research gaps and areas for further development. And Then there was a second phase, which was try to work specifically on these two major issues, which is identify host trees of pests and identify pest infections. And there were 4 working packages. Generally, as a conclusion, so I think also general conclusion also from today, we can say, I mean, that there are many platforms that we can use. So there are also various remote sensing sensors. We just can group as optical, thermal, and microwave. These have various spatial, spectral, and temporal resolutions and offer information valuable for certain plant crop types, also on the healthy status. But of course can provide information on pest symptoms, but not on presence or absence of a specific pest. Not yet, I mean, at least. And also the major limitations in the application of remote sensing plant health, we can summarize this as the low resolution of freely available satellite platform. We have heard today the Copernicus program, Sentinel-1, Sentinel-2. Of course, they are not I cannot say they are so low resolution. So when we speak about crops, we have to have, of course, a higher resolution. But it can be useful for forestry or for vegetable crops. I mean, we can say that they may have an use, but there are some limitations. But these are free as a cost. Of course, if we want to rely on high resolution imagery, unfortunately, the costs are still high. And, but doesn't mean that they cannot be used. I mean, as I say in the beginning, it's economically more convenient. So we have to think that an outbreak create economical losses. So we have to also consider that this cost could be convenient. And the other weak point is that we have sensors, for example, those ones that we want to use on unmanned vehicles, on drones. They may be, when I say a few, that may have a range of wavelengths which are also feasible to detect pests and diseases, and expensive, still expensive. So if you want to use a drone and put a sensor which is expensive on a drone, you may risk that it can be also destroyed. And high weight sensors, so sometimes you need really an aircraft and not a drone. I mean, the drone must be an heavy drone. But the problem is that we have not yet a specific pest specific sensors, which means that they have a wavelength range so large that they can really detect specific pests. And also lack of harmonized data quality and lack of skills for data processing interpretation with a competency in plant health. Of course, there are many other limitations, but these are probably, we can say, that are the major ones. And so we say that what is available now, we have seen also this morning, Sentinel is very nice tool because it's always available. We have a lot of data that we can use for vegetation classifications, and so which is very important also to assess the distribution of the plant, the pest plant host species, and also may provide information on temporal resolution. Other platforms provide higher resolution images, but are expensive, but can be used, as we say, because it could be convenient to use. Applications, semi-automatic and automatic counting of plants are very helpful for processing images and have, of course, supporting the monitoring and surveillance program in order to size the program and to also select the best sampling procedures for survey. And application of pest recognition procedures, some are already available. Of course, in this area, a lot of improvement are ongoing in research, and we have seen the case of Citrus tristeza and Xylella fastidiosa. Now, this is what has been said that is also available, but of course there is a research which is ongoing or future. For example, for improving the performance of the development of a pest-specific sensor, we need, of course, to focus on the specific pest. So, for example, we have done this research on Erwinia millovora in pears, and we find out that secondary metabolite from the plant are produced specifically when the plant is infected by, in this case, Erwinia millovora. So if we select the specific metabolite, we can also associate indirectly the wavelength up to the metabolite and indirectly to the Erwinia amylovora. This approach is very effective because you can select, we should say, a wavelength package, which is, in this case, pest-specific to Erwinia amylovora. And so the research ongoing is also for Xylella fastidiosa in the project X Factors, and we're doing, again, the identification of metabolite specific to Xylella and the selection of the best wavelengths which are correlated to this metabolite, which are specific for Xylella. And so this approach can open a nice window to select a package of wavelengths, pest-specific for early identification of infections before symptoms development, so to improve the early detection, and also to classify host plant species which are specific to some pests. And so they can improve, of course, the sensors that can be just keep it in a drone or on a WAP, and so they can enlarge the wavelength as a wavelength package specific for a pest. And but not only the wavelengths, but also the vegetation indices must be. It's very important to develop new vegetation indices, and so the package of wavelengths, which are pest-specific, can also provide new information on new performing vegetation indices, which are more pest-correlated. And so this is the package of wavelength, the sensor, which are more specific, pest-specific, the new vegetation indices more pest-specific, so the image processing will be more accurate and pest-specific. I'd like to leave now the floor to Paul, so my work is over.
Excellent. So yeah, we're going to have we've talked a lot about sensors here today, so we're going to have a look at the sensor technology in a little bit more detail. Kind of focusing on what's available now, both in operational, what's available now in research, and what will be our holy grail, what we'd want in the future. So when we talk about technology in general, we talk about technology readiness levels. So we're using technologies at different readiness levels, all the way from the basic principles to this proof of concept, so 1 to 3, all the way up to you can buy the technology off the shelf and very user-friendly, so in an operational state at the moment. So we start off with the current operational multispectral sensor. It's the same sensor that Anna Maria just mentioned. And this is mounted onto a reasonably cheap drone platform. I think the sensor costs at least 4 or 5 times the amount of the drone. But it's operational, it's user-friendly, it comes with software that is easily programmable, it's easy to process the data. We call this specific sensor, it's a 4-band multispectral, so it collects in the green, red edge, and the infrared, so specific areas that are very relevant to plant health analysis. When we say discrete band, it means it's collecting the exact same area of the spectrum every time it acquires data. Sort of like your cameras in your phones have quite a lot of overlap between the bands of data, so that you can't really use them for scientific purposes. If we look at the current research sort of cameras we're using and developing, so this is a camera that we're developing at Ferrer Science with Newcastle University and the Rutherford Appleton Laboratory in the UK. So this is kind of like the TRL level, sort of 2 to 3. It's at the pilot stage. We've got proof of concept. We've got the sensor flying on a drone. And when we say it's hyperspectral data, got the graphs down here. With this camera here, you've got 4 bands of data. In the same area of the electromagnetic spectrum, this camera is collecting 41 bands of data. So we're getting a lot more spectral data from this camera, which will enable us to, in the future, hopefully identify these packages of wavelengths for certain and specific pests and diseases. So when we look at the future sensor development focus, we're going to continue progressing these research sensors as technology through to TRL levels. When that gets to an operational level, it may not be so much a buy off the shelf because it's going to be very expensive. And when I don't mean very expensive solely as in cost, I also mean expensive as in knowledge to use that camera. So it takes a lot of knowledge to understand the camera and process that data. Second area is identify areas from these sort of research grade cameras of the electromagnetic spectrum, these packages of wavelengths for detecting specific biotic and abiotic stresses. So just using this as a complete example, so we take that hyperspectral data, we could possibly identify 2 areas of that data that are relevant to a specific pest or disease. Then we don't have to have this very expensive camera, very heavy camera, very large drone to carry the camera. We can then develop smaller, cheaper sensors, because technically, for this specific pest or disease, we don't have to collect any of this data around these two peaks. All we have to do is collect there and collect there. So that gives us the opportunity to develop cheaper sensors, decrease the data volume dramatically, and what that helps is decrease processing time and decrease analysis time. So it's actually making these specific sensors a lot more user-friendly. That's something we've got to focus on all the time, is making these things user-friendly. So platform technology must be considered. I'm using the example of drones here just because it is an area that is increasing, we've heard about today, increasing so quickly. To get a satellite system into orbit takes a lot more work than it does to take a drone and put a sensor on the drone. So a lot of the sensor development is happening at this sort of scale because it just is easy to get these cameras up and down. So just to, well, we first started getting involved in drones was 2015, sort of beginning of 2015 at Ferrer, and they were fixed wing, large wingspans of 6 foot, same as me, bespoke, made to order drones, so sort of handmade, bespoke items are very expensive. Over the past few years, we then have these little, almost hobby drones that you take the camera off that comes with it and put a different camera on, and it works exceptionally well. This is still one of my favourite drones to use. And moving more into the present, this is kind of our research drone. It's large, it has a large payload capacity, has our research camera on. You know, it is slightly nerve-wracking because flying that, as Anna says, because it's on a drone, and if that crashes, that's the only camera in the world that does that. So it puts a wee bit pressure on the pilots, which is actually me and my colleagues, so we have to make sure it's working properly. And then moving into the most advanced UAVs we have at the moment, so dual sensors, exceptionally easy to use, easy to program, easy to fly. So in the space of 3.5 years, we've moved a very, very quick way in this platform technology. So development of drone platforms, it's progressing at pace. However, we've heard about it a lot. Current legislation restricts the use of these drones. In the UK, it's very similar. Across Europe, we're allowed to fly as high as 400 foot and 500 meters of the pilot. So if we were, I've spoken briefly earlier on about putting the drones and the technology into the inspector's hands, into the farmer's hands. And if we were to do that, we need to be producing light platforms, cheap platforms, more automation, pre-programmable to the area of interest. So in a farmer's context, he buys a drone that's programmed to his farm. So he wants to analyze a farm, one of his fields. One day he just says field number 1 or the name of the field, and it goes off and surveys. That's what you need to get to. And then also automatic collision avoidance and geofencing improvements to satisfy legislation. I mean, collision avoidance has come on a huge way in the past 3 or 4 years from your hobby drones, like people going skiing or mountain biking over having a drone following them. They have automatic collision avoidance, so if there's a tree in the way, they'll move out of the way. And geofencing improvements, you know, having the geofences around your field so the drone is not allowed to fly. It's literally booked into a 3D area space. It can't go higher, can't go further. And creating that all automatic, that's when these things are really going to get into the inspectors and the farmers' hands. But it's not all about drones. I do talk about it a lot. These sensors, I like to probably better to call them near-ground sensors. They're deployable on drones, yes, but they're also making them able to be deployable on current machineries like tractors and mowers. If you're analysing an orchard, you don't want to go and fly a drone, it's creating another job for you. So how can we get the sensor on the back of the mower while you're mowing that orchard and collecting the remote sensing data whilst you're doing another job? So it's not creating more work. And also handheld instruments. The hyperspectral camera that we've got on the drone now started as a handheld instrument and still being used as a handheld instrument. So we've heard a lot about the freely available data and the satellite platforms. We talk about this multi-layered approach, and it is important to use the near-ground sensors, the manned aircraft sensors and the satellite sensors. But having these ground results used for upscaling the satellite data to coverage these larger areas of land, which I spoke about earlier, but having more highly accurate ground instruments will enable you to be more reliable on those ground results, so you can train this freely available satellite data with a lot more confidence. So that's where we're going with that's where I feel the future of sensor research needs to be going. And then, does it go? I thought it was going to be.
Well, thank you for that. It's a really excellent presentation, and it's actually great because over lunch was having a conversation. We were talking about how important it is for both the end users to communicate user needs, but also for the remote sensing community to communicate what their capabilities are for providing services. And I think it's when you get information flowing both ways like that, that you make progress. And I think that's a very good summary, I think, and a very good overview of what is capable in the industry. Thank you very much for that. Right, good. We're pretty much on time. Now we have a short, unannounced presentation, and I didn't bring up my my list, so I'll have to read you, or you can introduce yourself.
Okay, yes, of course.
Hubert.
Yes, my name is Hubert Koneczny. I represent the remote sensing division of the Institute of Aviation in Warsaw, in Poland. And I'm very grateful for this opportunity because I wasn't included initially in the list of speakers, but I want to share with you the results of our project that strictly relate to the topic of the conference and topic of the presentations. Okay. Yes, that's it. I won't go very deep into the details and methodology. Let me just briefly introduce the project and show you the results. So maybe let's start here. The project that we were implementing, it's called HESOF. Here you can see the basic topic of the project. This is evaluation of the health state of forests and the influence of phosphate treatments with the use of unmanned aerial vehicle. And of course, here we can see two main objectives of the project. So basically, we wanted to elaborate this new methodology that allows to use unmanned aerial vehicles to monitor vast expanses of forests, as well as evaluate the influence of phosphate treatments in regards of the presence of Phytophthora, the pathogens of the genus of Phytophthora. HESOF was co-financed from the European Commission and was implemented by us between 2012 and 2018. We actually just finished this project in August 2018. Let's go maybe to the environmental problem, because this is very important. Why we even started this project? The very specific environmental problem was the forest dieback that is known in Europe since 19th century. Here on the pictures you can see some signs of this dieback. This is, for example, the defoliation of crowns, the damages in the structure of fine roots, or the discoloration in the bent wood. And currently it is proven that the main cause of this of the forest dieback are the fungus-like organism Phytophthora that lives in the soil and damage the fine roots of the trees. Okay, let's go to the results and the possibilities of implementation of multispectral images, because that's the main part of my presentation that I want to share with you. Okay, this is the first example, the basic classification. First of all, we started with classification trees by their classes, the coniferous and deciduous trees. We have done this mostly by using the near-infrared pictures. Here, only by looking at one picture like this, you can say by comparing the hue of the colors, where are the coniferous trees and deciduous trees. This is more explicit example of our work, where we just use more contrast color to show the results of this work. We marked with different colors, different types of the different classes of the trees for the given forest. And also from there we went one step further, and we've done the classification not only by the classes, but also by the species of the trees. Here on the right side, you can see the map with the colors, and the colors are representing a different objects and different species of the trees. Like the description says, light green are the Scots pine, dark green is the English oak, while with the black color we have marked non-living material like buildings or roads. A second example is more obvious. This is the health state evaluation. Here you can see those two curves represent the healthy oak and dried oak. Those are the spectral characteristics of these two objects. And if we take a look beyond 700 nanometers, this is near infrared band, you can see that the difference in the reflectance here is quite significant. So using the reflectance in the near infrared, we can easily distinguish healthy and dry trees. And this is a ready example of our work. On the left, we have used here the detection algorithm that allow us to detect the crowns of the trees. On the left, you can see the example. These geometric shapes are representing the single, every single shape is representing the single crown tree, and the colors are representing the condition of the vegetation. The red one is a bad condition, the green one is a good condition, so we can easily conclude that this tree in the south where the red color prevails is practically dying and it's drying out. A third example is the assessment of the level of deforestation. Here you can see the orthophoto map from 2014 and the same area 1 year later, 2015. And only by comparing these two orthophoto maps, we can spot the places where the trees have been cut down. You can go to perspective view, and I can tell you a little bit more about our work here, how we assessed the level of this deforestation, the area where the trees were cut down for the given part of the forest. On the right, the columns, each column is representing a single tree. The color of the column are representing coniferous and deciduous trees, as well as height of the column is representing the height of the tree, and the diameter of the column is representing the diameter of the tree's crown. Okay, let's go to the fourth and last example. This is the estimation of the concentration of chemical elements in the leaves. In this case, we estimated the nitrogen and phosphorus. And here are the three basic steps that we have taken to do this job. First of all, in the turn of 3 years, we were gathering the samples of the trees and measure them in the laboratory to gather the results. Also, we were acquiring pictures at the turn of these 3 years. After combining results from the multispectral images and from the work in the laboratory, we were able to find the correlation between first and the second. And in the first step, we have added the machine learning techniques to estimate the concentration of these chemical elements for over 4,000 trees in the given forest. If you are wondering what is the accuracy of this work, that was around 87 to 90% accuracy. And this is the ready example of this work. 3 years, 2014, 15 and 17, and the concentration of nitrogen represented with the different colors. Each dot on the maps are referring to the single trees, and the colors are representing different concentration of the nitrogen. The red one is deficiency, blue one is sufficient, and the green one is optimal. The same example for the phosphorus, and also we have checked what is the ratio between nitrogen and phosphorus. As you can see, the concentration were getting lower at the turn of these three years. That's because in 2015 there was a huge drought in Poland, and we have proven that this drought very significantly influenced the amount of nitrogen and phosphorus in the leaves. Okay, that is all about the HESOF project. Last slide, a few words about the perspective of of the usage of remote sensing in the plant health. In January 2019, we will start a new project called PhytoExport. This project will be implemented by the Institute of Aviation and with the, among others, main inspectorate of plant health and seed inspection. And the objective of the project is to help the inspectors with their field work by implementing remote sensing techniques into precise agriculture. From the here I listed the general work that will be done by us, by the remote sensing division, and also by our partners. But the remote sensing division will mostly focus on monitoring of the whole vegetation cycle of the plants, also on early detection of the pathogens and the influence of the weather condition for the whole vegetation cycle. And this areas directly refers to thing that was said today in the morning, that remote sensing not only consists about detection something that is visible, but also that something that is not visible. And in this case, this is of course the presence of the pathogens or the microorganisms that are harmful for the plants. Okay, that's all. Thank you very much for your attention.
Well, thank you very much for that as well. I think, again, another very good exposition of what can be achieved with these techniques. And certainly for me, coming to your community as a bit of an outsider, I'm really impressed by that. I don't know if you are all as impressed at that, but I think if I was a young person today, I would find some very interesting projects, and I would think a career in this field would be extremely exciting. And then I think that also then touches on the question that we've also had today about training and about getting people in this field with knowledge and expertise. Good. Well, I think we move on. We have a session now dedicated to sort of discussion. I'm not quite sure how to organise this. Maybe we can sort of have this as an open discussion. I think we left one question, which was a sort of political question, a little bit about how this field can be seen to be organised at the more political level. We left that question open. I think from the presentations that we have just seen as well, we've seen also that the development of the remote sensing technology, and how we match that with user needs, and how the users can express their needs towards the remote sensing community to improve the development of these technologies to create really useful applications. So I think perhaps we can open the floor maybe to comments and questions. If there are any specific questions addressed to the recent speakers, you may do that, or maybe I leave you to make comments and questions, please.
Well, I think we have seen very good applications at the detection of pests and diseases, either early detection or late detection. But another strategy, to contain the spread of the diseases is to perhaps propagate individuals that are naturally resistant to those diseases. And I'm working now with a group of pathologists, and we are trying to identify pockets of resistance in areas that have been infected by any pathogen. And I was wondering whether anybody in the audience knows about any application of remote sensing that can assist us to locate those individuals that are genetically more resistant and therefore can be propagated through tree breeding programs.
I think that sounds like an interesting question. Let's see, our last speakers there who perhaps Anna Maria would...
Well, I'm just answering in this sense. Well, because we detect some differences, among susceptibility of the over the not only species but also as a variety cultivars. And you can do that, you can detect that by remote sensing. So this different response inside of even on a species or among species provide you some at least indications on susceptibility, which cannot be resistance, but can be at least tolerance. But anyway, you have to go and then investigate, of course. Exactly like we don't know who is the responsible or the stress could be that, but then you have indications. So because on a large scale, you can evaluate if, for example, we do for Xylella and for inside the olive trees, we have a variability in susceptibility and so in symptoms expression. So this give you indications on tolerance or resistance of some cultivars or species, depending which are our target.
Thank you. Yes.
Marcel Tonen, Tuinbouw. I think your main question was how do you bring providers and potential users together? And for us, we are now looking into the possibilities what we can do with remote sensing. We are plant inspectors, so we don't know anything about video systems or image analysis. So we really try to build collaboration with the service providers. So we have a number of interests, diseases we want to detect, and we're trying to find the right partners. And I think being here for me was really good to meet some of the people who are on the application side. We can bring in the knowledge about plant diseases, and together we will be able to develop the technologies and apply the technologies later in practice. I think that's my way of going forward in this.
Well, actually, I'd like to maybe just delve a little deeper into that, because then if you are coming into the world of, or you're approaching the world of remote sensing from outside of it, I mean, how do you do that? How do you find the people to talk to in the first place? Were you aware of Copernicus? Were you aware of aerial survey companies? I mean, how did you think about getting into this or asking these questions?
Yeah, so we are in the X Factors project, so we knew about the work that was being done for Xylella. In the Netherlands, we tried to hook up with people. First of all, we started a project with students, which is nice but not very applicable. And from that, we just looking into the internet, trying to identify partners you can work with. And now I'm talking to a lot of people, finding out there's a lot of people working in the area. But you have to identify them, and the only way to do that is go out, talk to people, and yeah, more or less, you really have to find them. There's not a list somewhere where you can find it. And secondly, I think you also have to find the right partner. We discussed about science and application, and somewhere in between, there's also a group of people who try to develop the technology into a practice. So mostly scientific people, they go on with the next scientific question, and they do not finish the technology, but there's another group of people that develop it into something that we can use in practice. Mm-hmm. And I think it's important to identify also those people, to bring them into your project, to make it an applicable application.
I think that's very important. And I think one of the things that interests me is actually getting, because I mean, we've heard nice talks about the technology for remote sensing. Now, generally, the people who talk with enthusiasm about hyperspectral sensors will be physicists and engineers. And they can build these things. They're very clever people, but they probably have little knowledge of really what they can be used for in the downstream. Mm-hmm. And yet the downstream, the people in the user communities, if you talk to them about a hyperspectral sensor, they first of all don't even know what you're talking about. So it's getting the physicists and engineers developing the sensors to talk to the biologists, people who understand really a completely different world. It's getting them talking together to mesh the user needs with the service provider capabilities. And this is, it sounds so easy to say it, doesn't it? But it doesn't happen very easily. It happens because people come to conferences like this and bump into somebody by chance or because they're actively looking to join in European Commission funded projects and they accidentally find a project that is interesting. But it's a very difficult thing to make happen, but it has to happen in order for this progress to be made. I don't know if anybody else has had any experience that they would like to relate about that. Yes.
Yes, my name is Nico Hartl from the Netherlands, and I would link up with what my neighbor said. I think actually we have heard now what's possible, at least get an idea of what's possible. I've also heard a lot of abbreviations which I don't understand. But I think perhaps we should, as plant health people now, think can we formulate the problems that possibly can be solved with the technology that's possible, that's available. Technology development will go on. But perhaps we could, as a group of plant health people, sit together and say, oh, this is an idea. And then come in contact with people like running these projects already, also even an Euphresco project is going on. So the links are there. But knowing this, we should think what possible problems we would like to solve. Thank you.
Yes, I think one of the most important things you can take away from this conference actually would be the participants list, and I mean that. Sorry, there's a comment here.
Yes, I would like to give you an information that this information is the example for using the remote sensing in Hungary. It's not for plant health reasons, but very close to our field, and the work is done by the Plant Protection Authority. We are using it more than 10 years ago for the detection of infected ambrosia fields. And first we used the assessment of satellite photos for this monitoring program. But it turned out that several times the fields, on the fields weren't ambrosia, other weeds were there. And later on we turned to use of helicopters. So this system actually is used with helicopters. And there is a plan to develop this work on drones as well, to have more or bigger areas to be monitored in this way.
Good. Okay.
And it is very, very effective. After identification of the infected fields, they have to be destroyed.
Yeah. Okay. Thank you. So behind you, yes.
I just want to agree what you had said. There are several types of meetings and conferences which bring together actually researchers and private companies and users. And there was a big event in Riva del Garda last year about integrated plant production. It was a big conference, and they invite especially also companies developing things, and they can listen to the problems which the producers have or advisory service have. They can see what researchers are working on in their area, and then they offer products, and they know before. And this is something, it's really impressive what's going on already outside, and small companies developing things and really addressing needs and trying to produce tailor-made solutions for different types of users. And I think it's the only way how to bring people together. And on a national basis, there are meetings. For example, we have a meeting, National Plant Protection Organization, and we were very surprised that there was one company offering a presentation about how to use the drones for the application of trichogramma against the mice pest. And everybody was very excited, and they said, oh, this is not new, this is existing since several years already, we just wanted to present it to a wider audience. So there is much more ongoing already, the direct contact between producers and companies, for example. But what I really wanted to ask is, Martin Watt has asked the question, will it be possible for those who have given a presentation to really, is it possible to give a range of options, how or which information can be provided, how fast, for which input, budget input, to give information in case of an emergency? As far as I understood, this was a question of Martin this morning. I think it would be really interesting to see. And maybe the Plant Protection Services could try to formulate some of the most important questions they have related to remote sensing and the development of the techniques. So what do they expect? Which problems can really be solved? Where do they need a solution? What are the parameters they would like to have answered from science and development? So I think there is a lot of things which could be arranged. The information is there, but it must be structured and offered. So maybe this could be an idea to start a process in this direction.
I think that sounds very interesting to me, as an outsider, but actually that one of the important things that comes out of this conference is not an answer, but a question. And I would leave that question as a longer term question for your community to answer. Sorry, there was a question over here.
Yes, but it is, in fact, it is really in the same direction as Sylvia was saying. It's about the problem formulation, because we are really in a phase where we have to go for this problem formulation before trying to cross-fertilize again with other sectors. Because the type of problems we have been looking at is one pest, one host, but we can go much broader and try to characterize an ecosystem service. We can try to see an habitat. We can look at multi-stressors that could have an effect on bees. We could go so wide. So we still have to really work on this problem formulation, because this technology cannot do everything, but can contribute to everything. So it's difficult. It's tricky, I think.
Okay. Martin, do you have a...
Yes, one of the things we've been trying to work at with our member countries over the last few years is improving our contingency planning and the way in which we exercise our contingency plans. And we'll have a workshop in Serbia at the end of November for an outbreak of something on a forest, in a forest area. And the scenario, of course, is top secret to the planning group. But it's possible after this week that there will be some sort of inject which says during the 2 months of scenario that we'll look at, your Ministry of Science has provided €100,000 for bringing remote sensing technology to bear on this problem. Can you do anything with it? And I think I would be writing to the presenters of this at this colloquium to say, are they willing to be in on the exercise and possibly responding to questions which are formulated and developed for a rather specific scenario there, and are they then able to answer that question? As you say, so the question is left hanging for the moment, but if they are willing to participate in that exercise, it might come back in a more concrete form at the end of November, given that we're only there for 3 days, about half an hour in which they can respond with sort of ideas as to what might be possible. And what I'm hearing is that, you know, the answer is, yeah, there may be things that can be done, at least in terms of host distribution or in terms of looking for large areas of sick trees or whatever. So I think that will be... And there are 1 or 2 places left on it. Certainly if a remote sensing specialist wanted to come along and experience what these people are faced with on a day-to-day basis, those who are heading national plant protection organisations, we could squeeze one in, I'm sure.
Oh, good. And I think that sounds exciting.
I would like to try to answer to the question this morning of Dr. Di Rubbo. How can we, in reality, if I understood, we can try to make this approach at the EU level, I mean, among, if I understood. In reality, we are doing something similar for the data acquisition in the field using the Xylella, Foxylab EU. No? Try to harmonize at least the accuracy in data acquisition, which is very important. So in reality, we could do something also in the remote sensing technology, because what we find out in this project that the sharing of data is very difficult, because data are not harmonized, are not normalized. So in reality, it's very difficult to manage this type of data. So it will be advisable to start to try to approach, no, in this sense, I don't know, Paul, if I'm saying correctly, but to try to first to select some laboratories, some in remote sensing, of course, and to try to make a sort of ring test, like because I'm coming from analysis, so, but in reality it's the same thing. We have to harmonize, normalize data in order to share. And if you don't do this, it's very difficult to have this approach at the EU level. I mean, if I understood, I don't know, something like that. Yeah, for different crop and etc.
Good. Yes, I think that. So, I mean, are there any other comments on that issue as well in answer to the question? There's other. Oh, please.
Yeah. I will. The last point what I saw in my talk was that we have to really create a multi-source network. And one example is from the ESA, it's called Thematic Exploration Platform. And this is focused for forest, for water, and we can also establish such a TAP platform for infection, for plant health. It's really important. This is one comment, because there are the information are harmonized in this, the data are processes, the data are linked together in this platform so that we have not a problem for harmonizing, for using this data for big data analyze and so on. And a second comment is that there exists a plant phenomic facility. I don't know if anybody of them in every county exists for crop plants a plant phenomic facility. This is a facility where crop plants were analyzed by the physiology and collect all the information of remote sensing data in a lab. Every day, every minute, the crop plants are moving under the sensors, and a lot of information, spectral information for specific infection are collecting and give the basis for remote sensing. And this is really important that we know this or not know this information and integrate this.
Good. Thank you. Good. Is there any further comment or questions? Yes, please.
I have to admit it's a question to you as a chair of this colloquium, and probably it's not just fair because I didn't announce it before, but I would be interested in would there be some incentives for you or for the for your organization, the Euphresco, that you would think that especially in public green, that could be very much affected also by quarantine pests. And do you see some fields of cooperation of communities and your organization, and some links to the work of the plant health area or world?
Indeed. Well, actually, no, thank you for that question, because as I said when I introduced myself, I was a little bit skeptical about why I was here at all. But I have to say that, you know, I find it an extremely interesting day, and it is actually extremely relevant to what we do in Euphresco. And as I think I've been biased in the comments that I have made, because as I say, Euphresco is about trying to make these links between technical service delivery communities and development R&D communities, people developing stuff in the space world, to make links with user communities who are not aware of space, don't care about space, but could actually benefit from satellite technology. So that is what we are about. And of course, what I've heard today is almost a classic example of that. Okay, it's not solely about space. I mean, it's about remote sensing technology, which is a little bit about space and quite a lot about aerial and other forms. But I see that it's highly relevant to us. And I mean, unfortunately, we don't have very great resources, but I think it's something that I will certainly look at in the future, because I think this is clearly an area where there is a lot more work to be done. I mean, I have the feeling that there's a lot of people saying that they can do a lot of things in the field of monitoring agriculture, monitoring plant health. But I think when I come here, I get the sense that actually, although there's a great capability, maybe it's not actually being used, or it's everywhere that it could be, or to the best way that it could be. And so I think that it sounds to me as though there is work to be done on broadening this communication between the plant health community and the remote sensing community. And yes, I'm very interested in this, and I will go away and see if there is something that we can do in the future. And maybe even, as I mentioned at the start of the session, one of the things we're concentrating on at the moment is, well, one thing is our Space for Cities program. And as I've said, I think there is an element in there where green areas in cities are particularly important, and they're also particularly vulnerable in some ways, potentially to pests and diseases, potentially to environmental pollution, and so on. So I think there is a certain link there. And there's also another area that we're looking at is the satellite applications for human health, believe it or not, so plant health, human health. And we've been running a program where we're looking at how satellite applications can assist in things like telemedicine, but also environmental monitoring. So we're looking to see how Copernicus data can assist in the prediction of pollution events or air pollution events that could lead to human health issues. And I think there are parallels there, and I think that it's something that we certainly will look on. So I'm very pleased that I've been here today, and I've learned a lot, and I've heard some very interesting and exciting things, and I'm going to go away and try and make some things to act on out of this. So thank you, and yes. I see that there have been a steady stream of people already departing, and we're 5 minutes before the scheduled end. Unless there is a final question or comment, just please.
Yeah, maybe one last remark. We discussed a lot about vision technology in the field, but I think there's also a large area of remote sensing where you use sensing, for example, in laboratory. So this was really the field scale, but also disease analysis can also be done on a plant level or even on a seed level. So maybe for our next meeting, that would be a nice topic also to discuss.
Well, Martin, would you like to say a few words to close? Or bow the same? Okay. Oh, yeah.
He may be about to say what I'm about to say, but we'll find out.
Would just like to build a bridge with what you just said. So there is a topic that is currently in discussion for funding through Euphresco, which is about the health of tree in urban environments. And there would be a number of activities, including a symposium to exchange knowledge and identify new survey techniques. So I think there is there the possibility for EURISI to contribute, to work more tightly with plant health and to build the future.
Okay.
I will send you information about this.
Thank you. Let's talk about that, yes. Thank you.
Thank you very much. Yes, image analysis and a lot of the image analysis work. Have there ever been any image analysis diagnostic projects within Euphresco? I'm aware of things like seeds and identification of seeds and so on, but the actual analysis technology of analyzing images is similar.
Yes, seed producer already have worked on this topic. For example, there is a startup which name is Next Seed, We just investigate when the seed just germinate.
Okay, thank you very much. If there's feedback on the day, please provide it, I think probably to Baldissera. We are looking at the possibility of having another science seminar after the next council meeting. That will be considered by the Euphresco and EPO governance arrangements. But I think today has been, for me, has been a great success. And I'm very pleased that Toby was able to come and chair it and help to sort of represent that bridging between different disciplines, I think, which we've heard is so important, that we recognise is so important. It's also saved me having to chair it through a heavy cold. So
yeah. The pleasure is all mine.
And any ideas about what we might do, what we might learn in future from another subject within the Euphresco area remit to cover? Would also be very interesting. So I don't know, Baldi, is there anything else that you want me to? Otherwise, I think we just close with a round of applause for the speakers. And another one for our chair. Thank you.
Thank you very much.